Back everybody, this is Noah, and in this video we're going to change topics a little bit. We're going to move on to basic function operations. So what that means is we are given a function with a symbolic description generally, and we could do this in other forms as well, but we're going to just stick with symbolic forms today. And then we can plug something more complicated than a number in, or we could take the function and add something to it, subtract something from it, or multiply that function by something. The lesson today is going to stick with some pretty basic function operations. We can do a lot more complicated things. And in Math 111, we'll get into transformation of functions and how we can actually edit graphs using some of this technology. And then you can even do more interesting things like multiplying two functions together or composing functions with each other. And so in Math 111, we'll get into some of that stuff here today. And in this class, we'll just look at some of the basics where we're just doing a few small edits to a function. So the example we're going to look at to give us an idea of what we're talking about here is we're given f of x equals 6x plus 1/2. And we want to simplify the following expressions, the first of which is f of x minus 2. So I like doing a little exercise with this before we jump straight into doing this problem. I want to start with something a little simpler. Let's just say, what is f of 2? Like, what do we do with the 2? We would take the 2 and we would plug it in for the x. Yeah, that's the way that we evaluate a function. So we take the number. We have the x is really a placeholder for where we're inserting the input number. So we're inserting 2 here, so we plug it in every time we see an x. What if we're plugging in something like a different letter? What if I plug in an a? Well, then I would take the a and I would put it everywhere that we see an x. So I'd have 6 times a plus 1/2. What if we had f of triangle? Here I would take the triangle and I would plug it in for the x and get 6 times triangle plus 1/2. I'm like, well, why are we plugging a triangle in? Well, it's just a symbol, right? It's just, it can represent a number, it can be an object. With arithmetic like this, we're assuming the triangle is a placeholder for a number, but it's just a symbol that's holding that location for us. If I try f of something more complicated, like f of car. Well, car is just a set of symbols that's a placeholder, and I plug the car in where I saw an x. You do this with a picture of a car. Say f of a picture of a car. This is my quick doodle of a car here. And so I would do the same kind of thing. 6 times the picture of a car. And then plus 1/2. So if I have something like f of something, I don't know, like a minus b, I take and I plug in an a minus b where I saw the x. So 6 times, parentheses, a minus b, close parentheses, plus 1/2. And this gets us to the whole idea. Those parentheses is where we plug stuff in, right? And so anytime we see an x in the original expression, that's where we would plug that same thing in. So that's the idea here. So let's look at a again, and this is now hopefully a little more apparent of what we're doing. Is we have f of x minus 2, I'm going to take the x minus 2 and I'm going to plug it in where we saw the x before. So I'm not putting the minus 2 at the end, I'm putting it in where the x was. Now we can simplify. We'll distribute the 6, get 6x minus 12 plus 1/2. And then a little fraction arithmetic here. 12 plus 1/2, this is 24 over 2 plus 1/2, right? We have to get a common denominator there. So 12 equals 24 divided by 2, so that I've got the same denominator. So these add, oh, sorry, we need a negative 12, don't we? It doesn't work otherwise. Negative 24 halves plus 1/2 is negative 23 halves. So we can say that this is 6x minus 23 over 2. We'll just leave it like that. All right, same kind of idea. Oh, I messed up the number here. Let me fix this real quick. So take a second. C, delete, C. C, period, undo, space. Okay, sorry about that. Same idea for C. We'll come back to that. Let's do and compare this with part B in the top right. Here we're having f of x, close parentheses, then minus 2. So this is different. And I'm not plugging the minus 2 in with the x. Here I'm subtracting 2 from all of f of x. So f of x is 6x plus 1/2. That is, let's do this in a different color here. That is what f of x equals. And so I'm taking that and replacing f of x with its description symbolically, and then we subtract 2 from it. So now I have 6x, and positive 1/2 minus 2, that's going to be minus 1.5, right? Or minus 3/2. So 1/2 minus 2 equals 1/2 minus 4/2 equals 1/2. Equals negative 3/2. Okay, so we see that we are not getting the same thing. So you need to be really careful here that you're plugging things in correctly as we're doing these. Let's move down to part C. Let's go back to red here. So here I'm plugging 3x in for x, right? So we'd have 6 times, now that 3x is the input. So I go 6 times 3x, then plus 1/2. And so this is 18x plus 1/2. And then we're done here. Note that the 6 times 3x, 6 times 3x, this is the same as just 6 times 3 times x. And some people might ask, well, don't I need to distribute that 6? And not over multiplication, only over addition, right? So if I had like 5 times 3 times 2, I would not say that this is 15 times 10. This is just 15 times 2 equals 30, right? So we don't multiply that twice there, just to make sure that that's clear. All right, we've got one more here before we go on to something a little more complicated. So for part D, here I'm multiplying the function f of x by 3. So I'm going to bring the 3 down and go times all of f of x, 6x plus 1/2. So then this has addition, so I'm going to distribute the 3 across these terms to get 18x plus 3 times 1/2 is 3/2. And that's it. Again, these are not equal. So we don't want to think that those are the same thing, right? I'm not taking f of x. In part C, we're plugging 3x in for x. In part D, I'm taking f of x and multiplying all of it by 3. So they have different interpretations here. And we're going to see this in some applications in the next topic, right? Not the next video where we do the now you try, but the next topic. Let's go ahead and move on to this next one, where we're really going to put all of this together in some interesting ways. So we're given a new function, j of x equals 7x plus the square root of 2 minus 5x. So we're asked to, given that definition for a function j, to simplify negative 2 times j of 3x plus 1 minus 5. So we're going to do this in a couple of steps. We're going to start with what is j of 3x plus 1. So we're inserting 3x plus 1 into the function j here. So we're going to get 7 times, and we plug 3x plus 1 in every time we see an x. So I have 7 times parentheses 3x plus 1, close the parentheses, that's replacing the x from the first one, then plus square root of 2 minus 5 times, and here we have an x, so we're replacing the x with 3x plus 1. Close our parentheses and close the square root. We'll go ahead and simplify this a little bit. So we'll distribute the 7 across. This is 21x plus 7 plus the square root of 2 minus 15x minus 5, and then close our square root. And we can combine like terms inside the square root so that our final line says that this equals 21x plus 7 plus the square root of negative 15x minus 3 when I combine the 2 and the negative 5. All right, so we're definitely not done. All we've done so far is plug the 3x plus 1 in. Our next goal is going to be to say what is negative 2 times j of 3x plus 1. So we know what j of 3x plus 1 is. It's what we have above. And we're going to multiply all of that by negative 2. So I write negative 2 times, in parentheses, all of what we got for j of 3x plus 1. 21x plus 7 plus the square root of negative 15x minus 3. And then we'll close the square root, close our parentheses for j of 3x plus 1, and then we'll go ahead and distribute the negative 2 across to get negative 42x minus 14 minus 2 times the square root of negative 15x minus 3, close the square root. And that's completely simplified there. All right, so we have one more step to all of this. We still need to subtract the 5 as our last bit. So we want negative 2 times j of 3x plus 1, then minus 5. So we're going to take everything we got from above, the negative 2 times j of 3x plus 1. It's the negative 42x minus 14 minus 2 times the square root of negative 15x minus 3. Close those parentheses, and then we subtract 5 from that on the outside. And really here, those parentheses aren't doing a whole lot because we're just going to combine like terms. There's no multiplication to distribute across the parentheses, across the addition and subtraction inside. All we need to do is combine the minus 14 and the minus 5 here so that this becomes negative 42x. Negative 14 minus 5 is negative 19. And we'll bring down the minus 2 square root of negative 15x minus 3. Close our square root. That's it. So go slow there. Don't just don't take this for granted. Rewatch this if you're not fully getting it. Try and make sure you can pause and think about each step. And then make some notes, and then we can talk about this more in class. But also go ahead and give the Now You Try problem a go, and then I'll explain that one in the next video. All right, thanks so much for watching, everyone. We'll see you soon.